Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So in this video, we are going to learn the last probability distribution for discrete, which is hypergeometric distribution. A hypergeometric experiment has the following properties. So we have a sample of size n is randomly selected without replacement from a population of n items, meaning that we have two sample size. We have two different focus. Okay, the first one we have population, and then we have the value for the sample. Okay, so in the population, we have to know the number of population given it is a big N. Okay, so this is the number of population. Meanwhile, for sample, it will be N. Okay, small n, given this is the sample size. So number of sample. Okay, and then the second one, in the population, K items are classified as success. Okay, so K is defined as number of items or number of success in population. So of course, N minus K items will be the number of failures. Alright, so these are the parameters involved in the hypergeometric. Okay, the first one is N, number of items in the population. K is number of items in the population that are classified as success. And then we have N, number of items in the sample. And the last one, X. Okay, so X will be the number of success in the sample. Okay, so this is what we need to find, okay, for the hypergeometric. Okay, so KCX will be the number of combination of K items taken X at a time. Okay, so we need to know the number of population, number of success in population, number of sample, and we can identify the number of success in the sample. Suppose that we have a population consists of n items. K is the number of success in population, and random sample drawn from the population consists of n items. So this is the number of sample. So X is the number of success in that sample. Okay, so this hypergeometric random variable X can be represented as this distribution, where Hg refers to the hypergeometric, N is number of population, this is sample size, and K is the number of success in the population. So this is the probability function for the hypergeometric distribution, where the probability of X equals to X is given as KCX, given K is number of success in population, C combination of X, where X is taken from this value, okay, and then N minus K, Cn minus X over NCn. Okay, so the mean for the hypergeometric distribution is given as NP, and for the variance, it is equals to NP 1 minus P times with N minus N over N minus 1. So how can we know our P? P is given as the number of success in population divided by the number of population. So basically, probability is the probability of success in population. Now let's try this example. Okay, I give you 1 minute to read this example. Okay, and you can pause this video. Okay, and then we will discuss the solution. Okay, so an employer randomly selects 3 new employees from a total of 10 applicants, meaning that, okay, here 3 is the number of sample size. Okay, so and the 10 applicants here shows the number of population. Okay, so for the population, given n is equals to 10, okay, and for the sample, we have to find n is equals to 3. Okay, and then from a total of 10 applicants, 6 men and 4 women. Okay, and here we have X be the number of women who are hired. Okay, so this is our main concern. We want to know our number of women who are hired. Okay, so we have to find the mean and standard deviation of X and find the probability that no women are hired. So now, from this population n equals to 10, we have 6 and 4. Given this is 6 men, and here we have 4 are our women. Okay, so X be the number of women who are hired. So this is our number of success, where number of success is number of women. So K would be equals to 4. Okay, so this is women getting hired. Alright, so for A, we need to find the mean. So EX, refer to the formula, the expected value is equals to NP. So we need to find what is our P. P is the probability of success, which is probability of women hired. Okay, given that we can take from the number of women in the population, divide by the number of population, okay, which is 10. So P would be equals to 0.4. Okay, so now just substitute back into the formula. Given your n is the number of sample, which is 3, times with 0.4, and you will get 1.2. And then now the second one is to find the standard deviation. Okay, standard deviation would be the square root of the variance. So given the formula of variance is NP 1 minus P n minus n over n minus 1, which is equals to the square root of 3, 0.4, 0.6, n is 10 minus 3, 10 minus 1. And you will get your answer, which is square root of 0.56, and this will be equals to 0.75. Okay, so this would be the answer for A. Next, find the probability that no women are hired. Okay, so this is the concern that the success is women are hired, but no women are hired. So meaning that our X would be equals to 0. Okay, so X equals to 0, just substitute into the formula. So the formula is given as KCX n minus K Cn minus X over NCn. Okay, so for our case, K would be 4, C, our X is taken from here, 0, N is 10 minus 4, C, 3 minus 0 over 10, C3. So you will get your answer, which is 0.1667. So this is how you solve the hypergeometric distribution problem. Okay, next, let's try another example. So a quality control officer reported that 25% from an incoming batch of 500 parts from a new supplier are defective. Okay, so here we have the value for the population. Okay, so given that for population, we have 500 parts, so this is our big N. Okay, and then for K would be 25% from the batch 500 parts, so it will be times 500, so you can get equals to 125. So this 125 is the number of parts that are defective. Okay, so here we have two separate questions, meaning that the first the number of sample is varies. Okay, so we will solve this separately. Okay, so for A, if 20 parts from this batch have already been installed in the machines, meaning that the number of sample is taken, which is n equals to 20, what is the probability that exactly half of them are defective? Okay, so this would be our x. Okay, so half of 20 would be equals to 10. So we need to identify this probability. So it would be k c x n minus k. So 500 minus 125 c n minus x divided by number of population and number of sample, which is 20, and you will get your answer, which is 0.0487. Sorry, this is not 0.0487, 0.0089. Okay, and then the next one, if 15 parts from this batch have already been installed in the machine, so these 15 parts refers to the number of samples. What is the probability that more than one of these are defective? Meaning that we have to find that the number of defective is more than one. So x will be greater than 1. Okay, so instead of finding x greater than 1, starting from 2, 3, 4, and so on, so what we can do is we can find 1 minus probability of x less than equals to 1. Since this one here, 1 is not included, so this one will be included. So x less than equals to 1, so we start from x equals to 0, meaning that the number of defective in sample is 0, and then number of defective in sample is equals to 1. Okay, so now we can find our probability. So 1, 2, 5, C 0, and then n minus k over 500 C 15. Okay, given this x is referred to this. And for the second one, this is your x. So it will be 125 C1, 375 C14 over 500 C15. Or if I write this in detail, it will be 500 minus 125, and then this one would be n, which is 15 minus 0. This one is 500, 15 minus 1. Okay, so you will get 1 minus 0.012 plus 0.0646. So the answer is close to the answer which I got, 9234. Okay, alright, so the next slide will be the exercise. So we have two exercises. So I want you to try this exercise first, and then later please refer to the next video for the solution of this exercise. That's all for hypergeometric distribution. Thank you.